Welcome back to another exciting chemistry lesson. In the previous lesson, we learned how to solve half-life problems, basic half-life problem. Now in this situation, we are going to look at half-life in terms of reaction rate constant and so much more. So here we have our first order reaction, as you can see here, concentration versus time. And the half-life again is half of the original, right? So 1.6, half of that is 0.8, and here you go. The half-life T1/2 is equal to 8 milliseconds. Now let's go in here and solve problem that involve half-life with K constant. So what we have here, again, when we work with half-life, we are working with first order reaction. We also learn in other lesson regarding K constant and how do we get the K constant from a graph. So let's look at this table before we solve a particular problem. For the first order, you notice when we have the straight line plot right here, which is y equal to mx plus b, this right here is your slope right here. This is equal to m, which is your slope, okay? So I'm going to draw this graph out for you because you need to be able to memorize it and draw it out for you, okay? So in this case, we have natural log of a versus t, and the graph looks like this. Well, the slope is equal to minus k. Well, of course, slope is negative. So you already know how to calculate for slope already. Well, I'm just going to write out for slope for you. It's y change of y over change of x. And you can choose any 2 points on this line. There you go. You learn how to solve for your k constant, right? In this case, it's negative k. But once you have the negative k, you get your k constant. Over here, for the second order, I'm just going to draw it out for you as well. See how I just look at this and I know right away. So 1 over a versus t, look at k. K is positive. That means the slope is positive. So the graph will look like this. Again, slope is equal to k. There you go. Here we have negative k. Here we have k. And the same concept, choose any 2 points to solve for your slope. Now, the next thing we are going to do is let's solve a certain problem. So we are given this graph right here, okay? And we are going to solve this problem right here. Based on the graph, determine the half-life of the reaction. Well, that's pretty easy. Start from 1.6. Here you go. Half of that, what's that? 0.8, and the half-life is 8 meters. See? 1.6, half of it is 0.8. And track it, the time right there. Again, half-life is measured in time. In this case, is 8 milliseconds. So I'm going to put 8 millisecond. There you go. Now calculate the rate constant. That's where it gets tricky. Remember we talked about this equation? You have to memorize this, although it's given to you as a data sheet, but you have to memorize it. So what we have here is T1/2 equal to 0.693 over K, right? And we are trying to solve for K, but notice we already figured out the half-life already, so we can cross that out, 8. So how do you get K by itself? Well, just crisscross. We'll bring that over. So K is equal to 0.0693 divided by 8. Now, what do we get when we plug this into a calculator? Well, 0.693 divided by 8. Go ahead, plug that into a calculator. What do we get? And that turned out to be 0.0866. There you go. And what is the unit going to be? Well, remember, this is a number. This is millisecond. Because sometimes they will take point off for getting the wrong unit. So if that's the case, so we have per millisecond. But in most cases, they don't really write that. They write like this. Millisecond to the -1. Okay? But you know, when we type in here, we have to use the caret symbol to indicate that part. Now, we have solved that our rate constant is 0.0866. And here you go, millisecond to the -1, okay? But in this case, we use the caret symbol to indicate that. The next question is, calculate the time in milliseconds that would take 50%, right, of the original C4H8 to decompose. So let's go back to our table. Now this is given to you as well. Look at this. We figured out the K constant from this graph, okay? Right there. Or in this case, from this one. So you have multiple options to figure out the K constant. The next part is we have this right here, which we can determine each specific variable. Well, right here we can look at the graph, right? But here we have time. Can we measure time? So let me write this out for you, okay? So in this case, we have natural log of A at specific time minus natural log of A initially equal to negative K. See how I just copy exactly from the table? And this is given to you on your data table, okay? Your formula sheet on your AP test. So let's plug it in. But this is where it gets really tricky. At A, see right there? What do we have originally? Well, originally we have 1.6, right? This is your original. But we only won 50% of it. So if 50% are decomposed, what is left? The leftover is what? Well, this is 0.5. So the leftover is 1, which is, 1 is equivalent to 100%. Minus 0.5 gives you 0.5. So we are going to focus on what is the leftover, okay? Don't look at this number. Don't get tricked. You use this number to get what's left over. So you time that right there, 0.5. So what we have here is natural log of 1.6 times the remaining, right? We want to find how much is it by using decimal. You should already figure out that, again, when we multiply by the decimal fraction, we figured for that particular portion, okay? Minus natural log of 1.6. That's original values. Now, how do we get K over here? Well, that's pretty easy. We just divide the whole entire thing. So divide by negative K, but I already know what K is going to be. K is what? 0.0866. There you go. Now let's plug in our calculator. In this case, let's use decimal calculator. What do we have? Natural log of 1.6. Go back to the main. 1.60 time. You see, if you have your own calculator, life will be a lot easier. Time 0.5. And the parentheses are there. And we are going to minus the natural log of 1.6, which we have originally. Okay? And then we press enter. And then we are going to divide it by negative 0.0866. And let's click on answer. Ooh, see? Go get yourself a calculator. Your life will be a lot easier. Divided by negative 0.0866. There you go. And before I type in the answer, we already know the answer by just looking at the graph already. It would be, right, it would be what? It would be 0.8 something. You would bet. Let's see. Oh, never mind. It's already given us answer already. Okay, fine. So there you go. So we can actually double check our answer as well, right? You see right there? So by just looking at the graph, we can make a good estimate. Hey, right there, at 50%, you would have that much right there. So again, this is the first half-life, right? Another half-life would be what? Would be somewhere right here, which is 25% of 50%. As you can see there, 0.5. So what's 25 plus 50? That is 75%. So again, everything worked perfectly. So in this case, what do we have? 8.00. It would take 8.00 millisecond. There you go. Isn't that nice? Beautiful. So we can just look at the graph and determine the answer from there. But what if it's not on the graph? Like in this case, how long would it take for 99%? Well, 99% used up. So 1 minus 0.99 give you what? 0.01. So I'm going to write this out again just to show to you. Negative KT. Okay. So again, this right here, the leftover is natural log of 1.6 times 0.01. See, we focus on the leftover at that time. Minus, that's where a lot of people get tricked on, okay? And 1.60 equal negative KT. So I know what's KT already. I can just divide it by negative 0.00866. So let's bring back our decimal calculator. So we have natural log of 1.6 times 0.01 parenthesis minus natural log of 1.6. There you go. Enter. And we take that answer and we divide it by negative 0.0866. There you go. And now what do we get? We got 53.187. Yeah, there you go. So we have 53.18 millisecond. So that's how we use half-life and how we can find the K constant in different situation. In this case, we use this formula, right? But be careful. Sometimes we have to use this one as well, especially for FRQ on your AP chemistry test, okay? And then once we figure out K constant, we just use one of the formula based on the rate order. In most cases, it will be this one right here, the first order. And as always, if you have any question, take a picture of your work, put it in the forum, and we will do our best to support you. We'll see you next time on another exciting chemistry lesson.